Swayam Prabha. Digital India. Educated India.
Students, we are going to discuss today about the solidification behavior for the three-phase equilibrium in the ternary system. In the last two lectures, I have given a vivid description of the three-phase equilibrium of the ternary systems, and I chose specific case in which there are two eutectic between the three binaries and one isomorphous. So, and then followed by I discussed about the isothermal sections and vertical sections. Today we are going to concentrate on solidification behavior of these alloys, and I am going to take this lecture using different sketches on the board so that you can understand it nicely. First thing I am going to discuss is to draw this space model again, so that if you have forgotten, we can again you can again revisit those things, and then I will discuss about solidification behavior using these things. So, let us go there. I am going to use this space model for all our discussions. The space model which I told you in the last lecture, consisting of two eutectic and one isomorphous systems. So, isomorphous will be between A and C, and eutectic will be between AB and BC. So, the isomorphous system between A and C is like this. This is your TC, this is your TA, and the eutectic is between C and B. So, C and B. Okay. This is the primary phase field of the C rich phase, and this is the primary phase field of B rich phase, and eutectic is like this. I hope you can see clearly. So, therefore, we term this as a eutectic 2 E2, and these 2 points I termed as C2 and D2. There is another eutectic between A and B. So, that I will draw it this way, okay, and this is little bit clumsy. Let me just draw it nicer so that you can see it clearly. So, this is the two primary phase field regions between A and C, okay, and these two are the primary phase field regions of A rechain and B rechain. Then I draw the binary eutectic, it's like this, U1. So, I term this as A, this is B, C, D, okay, and this is A1 B, A1 B1 better, A2 B2, and then I can connect. I know that I can connect these two eutectics. That is how this phase model will look like, and in fact, one can actually generate this triangular region between the three phases alpha, beta, and the liquid looking like this, correct. That is how I have drawn. So, three phase region here looks like a triangle. Now, I am going to discuss with you how the solidification will take place, right. So, let me just see where I have kept it, because this is all, yeah. So, what I am going to do is for you, let me remove this one. This is what I drawn in last class. let me remove this one and draw, and composition x, let us suppose the composition is given by this point x, okay. This is your x, and we are going to discuss the solidification of these alloy. Now, what is going to happen? Okay, first thing is that this is a liquid, as you have seen that this forms complete liquid in altogether, complete liquid, okay, at the above, complete means miscible liquid, and at lower temperature only this forms this solids, okay. Those are different compositions. Okay. They similar, like you can see here, the A reach of alpha phase will have this much of solute concentration, B reach will have this much, C reach will have this much concentration. Okay. Now, but in liquid it is all miscible together. So, therefore, as you cool down the alloy, nothing should happen below point, suppose 1. Okay. Let me just tell you this point 1, or let me just take this color chalks, that is easier for you to understand. So, point 1, this is the point 1 on which, I do not know whether you can see, this is the point 1 on which this line will cut this liquidous surface, because liquidous surface is a very complex one here. It goes like this and goes down also. So, that what when it cools down, it hits the liquidous surface as point 1, and at point 1, because it hits, so therefore, this will be liquid will be in equilibrium with the solid of a composition given by the point 2. Okay. Point 2 will be this one on this surface, you see this is the surface, okay. This is the surface on which this will be in equilibrium, correct. So, and as you go along, so this is the alpha, this is the beta phase rather, because this is the beta, this is alpha, this is alpha alpha, this is alpha, this is beta, okay. So, because of that, this is the beta concentration of beta phase which will form at the on the surface of the liquidus. When you cool down at temperature, suppose at liquidus temperature, this is the concentration composition of beta phase, which is B reach obviously, and the liquid phase. Now, as you cool it down, this is the way the liquid composition will change, correct. Similarly, this is the way solid composition will change, correct. That is how it will vary. So, one can actually draw varieties of tri lines, you can see here large number of tri lines you can draw, correct. So, this is how the things will change, but things will as you cool it down at suppose this is the point 3, okay. Let me draw, this is the point 3. At point 3, this line line or this curve on the liquidus surface will touch the surface on E1, E2, you can see here, this is going to touch that, and that means that this will precipitate also alpha, because this is the eutectic between eutectic reaction is what, liquid going to alpha plus beta, right. This is the E1 reaction, E1. So, because of that, this is going to precipitate alpha also, and what will be the alpha compositions, that we can get it, okay, very easily. I will just draw this one and show you. This is the alpha composition, I can connect. So, this is the alpha composition, and this is, suppose let us mark, this is 0.4. So, you have equilibrium, and this is suppose 0.5, you have equilibrium between 0.3, 4 and 5, okay. Let us draw it, color chalks, okay. This is a triangle actually which I have been referring you to always. So, the composition of alpha, composition of beta, composition of liquid will be given by these 3 points. One is 0.4, other is 0.5, and the last one is 0.3. 0.3 will tell the liquid composition, 0.4 will tell the alpha composition, 0.5 will tell you the beta compositions. Okay. And this is what will happen, this will keep on happening, and one can draw other triangles also at the bottom, like suppose I can draw a triangle between 7, 8, let me just draw this way, this is another triangle, and this is suppose this is 6, 7, 8, and similarly I can also draw another triangle below Okay. You can clearly see this will be sitting here like this. It might be wondering that how I am drawing these triangles. These triangles are drawn basically connecting points on the solid surface or the liquid surface here, and these two are the solid compositions alpha and beta. So, that is how the solidification will continue, and it will get over whenever it hits this alpha beta. This alpha beta plateau here between these, which I have shown you last class, solidification will get over. Obviously, from the space 3D model, it is very difficult to follow the solidification behavior. So, what we will do? We can actually draw these isothermal sections at different temperatures, that will be much easier. Okay. And how it will be changing, okay. Let us see that, then we will come back to this diagram. So, let me just draw one by one. So, first I will going to draw 9 such things. Okay. So, this is at T1, suppose T1 means at the temperature at corresponding to 0.1, and obviously at this temperature you have beta, and then you have a beta plus liquid and liquid. Okay. A, B, C. That is obvious. And where is my liquid where is my composition of the alloy? Composition of the alloy will be somewhere there. Okay. I am going to put a dot here like this. So, this is my X. So, at 0.1 basically everything is almost fully liquid, there is no solid, because it is just touching the liquid surface at T1. At T2 what will happen? At T2 diagram will slightly change, you are going to have alpha plus liquid, beta, okay, let me draw it this way, color, then it is easier for you to follow. So, this is beta, all green things will be solid for me, and any solid plus liquid region or liquid will be like this. So, this is alpha plus liquid, this is liquid. Again my alloy composition is somewhere there, X sitting. It will just form little bit of beta, as you can see here, you can draw a line, it will form beta. But things will be much clearer once you look at this one at T3. At T3 what is happening? You have to go back to by this liquid solid, the isothermal sections which I have drawn. At T3 this is very nice, very clearly you can see this is my beta, and then you have two solid regions, alpha plus liquid and beta liquid plus beta and liquid. Okay. So, what do you have? You have liquid, alpha plus liquid, beta plus liquid. You have a clear distinct beta plus liquid zone developed. That is what is here, beta plus liquid zone on the right side, and in this then it sits on this. As it sits on this, will precipitate more and more beta. Now, at T4 it will be very interesting actually. T4 is very interesting case. Let me see whether I can draw one more triangle here, because I have to draw 9 triangles. Okay, I can draw at T4. T4 is what you have fully developed alpha, fully developed beta, and fully developed also alpha plus beta zone. Okay. And then you have a liquid plus alpha plus beta. Okay. So, this is what is my alpha, this is my beta, alpha plus beta, liquid plus alpha plus beta, liquid beta plus liquid, and alpha plus liquid. And what is my composition here? Okay. So, you can actually join these 2 points like this. So, this is my X, let us suppose this is L4, and this is beta 4. So, volume fraction of the solid will be L 4 x divided by L 4 beta 4, because this is a tie line. You can draw a tie line through the two phase field. So, at T 4 only we come in we are going to see basically the connection between two phase and three phase fields. Now, it will be clear to you until T 3, basically T 3 is the temperature at which the solid is just about to form. T 2 it has not formed, T 1 also it has not formed. T 3 is temperature at which it has just connected, T 3 is here, you can see here 3.3. T 4 it will be like this. So, at T 5 it will be much more clear to you. At T 5 what is happening? We have a larger alpha region, beta also, and alpha beta will be much larger, and then you have liquid plus alpha plus beta also, liquid. So, what are the regions? This is my alpha, beta, alpha, alpha plus beta, and then you have liquid plus alpha plus beta. This is liquid, alpha plus liquid, beta plus liquid, correct. So, what you do here is that, yes, at this temperature it will even, because at this temperature actually the composition will sit on the liquid composition will sit on this line between these two phase field. Okay. So, this is my x. So, therefore, this will be alpha will start precipitating, right. Yes, alpha will start precipitating here. This is L 5 and this will be beta 5. Alpha will just start precipitating, not much alpha has formed. It will have larger amount of beta and liquid left over. Now, at temperatures T 6, this is T 5, things will little bit change. So, obviously, you will have larger alpha field, beta also, and then you have this, sorry, let me draw this one like this, liquid will be very less. So, this is your alpha plus beta, this is your alpha plus beta plus liquid, this is your alpha plus liquid, liquid, beta plus liquid. And at this temperature actually the composition of the alloy will sit inside the three phase field, because it was sitting on this boundary between two phase and three phase, but it will now sit inside the three phase field. So, it will be somewhere sitting there and it will precipitate more and more of alpha 5, and you can see this is the liquid. So, thing which is clear to you is that at temperature T 4 it was precipitating only beta, and beta composition was B 4, okay. And this composition of beta was in equilibrium with the liquid composition of L 4. At T 5 the temperature has dropped so much that the alloy composition is sitting on x, and x is basically sitting on this boundary between the two phase field and the three phase field, correct. So, therefore, it is precipitating still beta, it is not yet precipitating alpha, basically it will just thermodynamically it can start forming beta alpha. Now, at T 6 this alloy composition point moves inside three phase region, triangular region, you can see here, there it can precipitate alpha. So, that means what does it mean? It means that at this temperature eutectic reaction is happening, eutectic reaction leading to formation of alpha, and beta obviously will precipitate, beta was precipitating earlier also. So, primarily as compared to the binary phase diagrams, because binary phase diagram eutectic reaction or the three phase equilibrium take place at a fixed temperature. So, it is basically a non-variant reaction. Here you have a monovariant equilibrium. So, because of that this eutectic reaction can take place for a larger temperature zone, and that is what you see here. Although it is started forming here, there, it will also start forming at lower temperature. Okay, here I am going to draw it at T 7, T 7 is at a higher temperature, lower temperature than T 6, beta, alpha, okay, and this is the alpha plus beta phase field, and this is your this. So liquid is amount is also getting reduced, that is what you see here, and this is alpha plus beta plus liquid, this is beta plus liquid, alpha plus liquid, liquid. Okay. So, what will happen now? Obviously, nothing will happen except that these tri lines will keep on rotating. Which will it rotate? It will rotate in anticlockwise direction, because B to A to C is temperature is dropping, melting temperature is decreasing from B to A to C. This is TB, which is the highest melting temperature. So, what is going to happen here is like this, it will tilt this way. So, this is my alpha 7, okay. This is alpha 6, alpha 7 and L 7, okay, and your alloy composition is somewhere there. So, more and more alpha will precipitate, that means more and more eutectic reaction will happen. And now, at temperature T8 and T9, things will happen almost similar, okay. I am just drawing slowly so that you can understand it, because this is something which requires detailed understanding. Otherwise, so this is alpha plus beta plus L, I will remove it. This is beta plus L and alpha plus L, and this is your alpha plus beta. So, where it will be, this will again rotate tie line, this will be somewhere like this, and x will be here. So, alpha will be forming with the composition of alpha 8 is this one. Remember, in all these diagrams beta is forming, okay, because this is equilibrium between alpha plus beta and beta plus alpha, two phase fields surrounding the alpha plus beta plus L phase field. So, therefore, alpha beta both is precipitated. At T8 or T9 rather, the same thing will happen. Your 3 phase region will slowly decrease, as you see here. I am not drawing everything, so writing everything, otherwise it will be clumsy. So, here finally, this composition will sit on this point, and at this point basically both alpha plus beta, because slowly this composition point is going to enter into the alpha plus beta phase field. Finally, microstate will consisting of primary beta crystals and alpha plus beta eutectic, that is what will happen. And in that case, you have a basically when it moves here, the basically you can draw this is a triangle. So, this is your alpha 9 and beta 9. So, you can measure the alpha concentration is this divided by the whole, beta concentration is beta percentage is this divided by the whole length of the tie line, just like that. So, I can alpha 9, beta 9 and x sitting over there. So, percentage of alpha is nothing but, suppose this is x. So, x beta 9 divided by alpha 9 beta 9 into 100. So, percentage of beta is exactly same, alpha 9 x divided by alpha 9 beta 9 into 100. Because of space I am just writing there. So, but basically, so therefore, although it might be difficult to follow for you to follow the solidification pathways in this, but you can follow the solidification pathways nicely here. Basically what? Once you are able to draw the isothermal sections nicely, it is a matter of just putting a composition point there. Okay. Remember, the composition point is also liquid composition is keep on changing, right, as the more and more alpha and beta are forming, liquid composition is also changing. So, because of that, this point is also moving, going away from, it was initially here, then it moves there, then it moves there, then it moves there. You can see here how the things are changing. That is one point. Second point is you also must understand how the tie lines are rotating. Tie lines within this alpha plus beta or alpha plus beta plus liquid. So, beta plus liquid and alpha plus beta plus liquid, these two zones you have shown are also rotating in the direction in which the melting temperature of the compounds are changing. So, that means anticlockwise B to A to C, that is anticlockwise direction. So, I hope you have got little bit, or I am not sure whether you have got a complete understanding of the solidification behavior, but you have got at least fair amount of understanding that how the solidification is taking place. Frankly speaking, if I have to tell you in one sentence, obviously if I cool down initially, beta will precipitate first because beta has the highest melting temperature, B is the high melting temperature component, and because of the beta has the highest melting temperature phase. So, beta will precipitate first, beta will be in equilibrium in liquid till it reaches point 3, the liquid composition, which is going shifting from 1 to 3 till it reaches 3. At 3 both alpha and beta will precipitate, and that means what, the eutectic reaction will happen, and as you go down more and more eutectic reaction will take place, and more and more alpha plus beta phase will form, and finally this will end at a temperature at which your alpha plus beta, this thing, this 3-dimensional structure which I have drawn, alpha plus beta phase field will, this point 9 will sit on the surface of that. That is why the whole solidification will finish or get over. Okay, so same thing is seen here, liquid initially, then liquid is in contact with beta, finally liquid and beta crystal will, more and more beta crystal will form, then it will move into alpha plus beta plus liquid zone where alpha will precipitate, then it will move into there, more alpha will precipitate, more alpha means more eutectic, and finally more alpha, and finally it will move into alpha plus beta where the solidification will get over. That is how things will happen, and this is what you need to follow, correct. So, in the next lecture I am going to tell you a bit on this and further a phase diagram where we have only one eutectic and two binaries, two isomorphous systems, a variation of that, because this is what we can do. Peritectic and monotectic systems are much more complex, so we are not going to discuss those. Okay, in the next class I am going to discuss that.